Hey everyone, have a new video lesson for you today. We're moving on in chapter 13 to 13-2. Should be a pretty quick one. We got a lot of the introductory stuff out of the way. So this video is more of just an understanding of terms and different expressions having to do with graphing mostly. So for better or for worse. First things first, happy Star Wars Day. It's May the 4th right now. If you're watching it today, happy May the 4th be with you. If not, hope you had a great Star Wars Day. All right, so we're pretty much transferring a lot of what we've learned about triangles to a graph now. So it's kind of a new way of thinking about a typical graph. We know, of course, when you're graphing, we have a X and Y axis. And of course, based on a quadrant, at a typical scale, each mark is going to be worth 1. So you can plot points and draw pictures and stuff using different points and coordinates. So, like 1, 1 would be a dot here, 2, 2, so on. You got negative over here, so -1. This is all negative here. This is negative down here for Y. So that's your graph, right? So with what we're doing now in terms of triangles and geometry, we look at it in a different way. And so instead of marking things up like that, the first thing you do is, this is still X and Y. Now, the first thing you do is you start to label, it's like a clock. Basically think of it like a clock, right? In a clock, right, you've got your different times. And the hands, right, that come from the center, where they point, measures the time, right, or tells you the time. And so we're kind of going to do the same thing. The only real difference, or the main difference, is let me get rid of this, is we're now going to always start from right here. So we know this is X, we know this is Y. We're always going to start from right here. This is 0 degrees, okay? So that's always our starting point, is the right side. This is going to be 90, and you can see how that's 90, right? Because this makes a right angle, right? So if I start here, and remember, we're always measuring a line from the center, right? Just like a clock hand, you're always going around, right? So if I draw an arrow and it goes all the way to here, right? That's 90 degrees, because that's a perfect L, right? So if I drew this figure on a graph, that's a 90-degree angle, okay? So let's get rid of that. So this is 180. So for those that don't know, 180 degrees is a straight line. There's a perfect straight line that you can it's correct to say that the measurement of that angle is 180 degrees. That's a thing. And then based on the math, right, if each quadrant is 90, then you just add 90, and this is 270. And then what also that means is this 0 is also 360. And again, for those that don't know, let's say I started here and measured all the way around back to where I started. That's 360. And for those that don't know, right, a circle is 360 degrees, right? And that's always true. So that's why 0 and 360 are like the same point. But obviously 360 means you've gone around once and drawn a circle. So that's that. So hopefully that makes sense. These labels are really the most important thing to know. Now, the only other thing that you won't see too often maybe, but that you should definitely know is that, okay, that's just measuring if we go counterclockwise, right? That's going around like that, which is proper on a graph, because we start on the right side and then you go all the way back around to where you started. Now, if you were to go clockwise, it's negative actually. So obviously you still are going to start at 0 degrees, okay? If I were to draw and go downwards here, right? This is still 90 degrees, but because I went underneath, I went backwards and I went underneath to the negative part of y, this is now negative 90 degrees. So that's just a labeling thing. You can't really have an you technically can't really like draw an angle of negative degrees, but in terms of the graph, this coordinate and rotation plane, it's going to be negative 90, and then you just pretty much fill the gaps from there. That means this is negative 180, and this is negative 270. So what that means basically is that negative 90 is the same as positive 270, right? Because if we went this way, getting to this line is positive 270 going the right way, the correct way, I mean. If you go underneath, if you go the wrong way, the negative way, you get negative 90 instead. Yeah, so let me just write all of those here. Let me just get rid of this. All right, so this is 0. This is 90 or negative 270. This is plus or minus 180. This is 270 or negative 90. And this is, of course, 360 or 0. Or negative 360, I guess. Okay. So again, if I told you I had an angle, or if you had to graph an angle of 270, of course, you would just draw one line here, and then the next line you would do is going to end all the way here. So your angle is this, what looks like Pac-Man, right? You would highlight this, that whole rotation. So you just draw your end line here, and then this is what we're talking about. We're not talking about this side here. That's not correct. That's not positive 270. Yeah, cool. All right, so let's give names to those. You can read these all in your book. The initial side, what they call the initial side, is basically your starting point. So whenever you're asked to graph an angle of rotation, you always draw your initial side, which is, of course, on 0. You always start there, okay? The terminal side, so terminal, let me actually do a different color. So the terminal side is the ending side. They use the word terminal. So that's your ending side, okay? So if, again, like if I said my angle was 270, that means my terminal side, I rotate around until I get to 270, and then I draw my other side. This is the terminal side, okay? Because it's the ending. It's where the rotation stops. All right. This is initial because it's at 0. And then the terminal is where you end, where you stop. Okay. And then the angle of rotation obviously is how much you're measuring or rotating. So let's just do another example. So let's say I did, what's an interesting one? We could do like 100, right? Let's say we have to do 100 degrees, okay? Well, my initial side, I draw my initial side, is right here, always at 0. And then 100, so if we rotate, 90 is like right here, obviously, but we're not making right angle. We're doing 10 degrees more, so you kind of just estimate. Obviously, if you have a protractor, you can be more exact, but you just estimate. So if I go 10 degrees more, I'm going to say right here. That's my terminal side because that's where I end. And that's 100 degrees. It's an 100-degree angle, right? So it's bigger than a right angle. So that's why it looks wide, more open. That's that. And then we could do another one. Let's say we're doing, let's actually do like 5 540, right? So you can have more, you can of course have more than 360, because what that means is you draw your initial sign. We're going to 540. So one full rotation is back to 360, okay? And so we're gonna make sure we draw that. Sorry, so back to 360. To get to 540 is just 180 more, right? So we're gonna continue this, what's now a spiral, and now we stop here at 180 extra. So we're just gonna draw, this terminal side is gonna be on the 180, facing towards 180. So it's really a straight line. So 540 is a straight line, but you illustrate how you got there by drawing this spiral thing in the center, right? This spiral here shows that, okay, that you know you have to count a full circle and then keep going, all right? Cool, and then we can do a -1. Like if I had to do negative, let's do negative 300, oops, sorry, 315, okay, degrees. So we draw our initial sign, of course, is at 0. We're going negative, so we're going to go the negative way, which is downwards. Negative 315 is in between negative 270 and then, of course, negative 360. So we're going to be somewhere in here, or and somewhere in there. So here's our initial side. We're going to go all the way around to negative 270. And so you just have to pretty much estimate after that, right? Negative 315 happens to be 45 degrees more than negative 270. So, and 45 degrees is halfway in between, right? So if I just estimate and draw my terminal side, which is somewhere in the middle of these two, right? Then I just finish my spiral. That's where I end. And that's approximately negative 315 degrees, okay? So yeah, that's that. And again, it's this outside angle, right? Now there is a name for this part right here. So this is kind of the next section. Is this part is not the angle that you drew technically, right? Because you're drawing the actual rotation. The part that's left over here, you could call it, like left over, or how you really talk about it is you notice how, okay, the initial side, the starting point is always at 0, right? This yellow angle, it's obviously different number from the negative 315, but this yellow angle actually shares the same terminal side too, right? So the terminal sides are the same, right? So terminal sides are same. This means that they're called coterminal. This is in your book again. Coterminal. Coterminal, of course, meaning co, they share, or similar, and then terminal, right? Terminal comes from terminal. So they share the same ending point. Terminal means like ending point, right? So this is a coterminal angle, okay? And basically all that means is that they have the same sides. It's just that one of them is like part of a circle and the other is the other part of the circle, right? So if you look at it, yeah, I'm just gonna clear this real quick. So if we start here, right? If we have a circle, if one of my angles goes to here, right? So I've got this. The coterminal angle is the angle that is the rest of the circle, okay, to fill out the whole rest of the way, right? So let's say that, let's say that this red one was like, I don't know, 200 degrees, right? start here, you go all the way past 180 and then like 20 more degrees down. The yellow part, the coterminal angle, is what's left. And what's left is going to be, well, what's left of 360, right? Well, 360 minus 200, right? Because to get all the way to here is to 360, but we only went 200. So the difference is 160. But of course, since the yellow is starting here and then going negative, the negative way down, and then ending on the same side here, instead of positive 160, it's going to be negative 160. So this is negative 160. So you just do the difference between 360 and the angle you have. And of course, because you have to go the opposite way, you're either going to do it negative or make it positive if you started with negative, all right? So let's actually do an example of that. I hope I'm not going too fast. I know this is really new, so if it's confusing, let me know so we can do more practice. And of course, look through your book too. So let's do an example actually to help us. Let's say I had 120. Okay, so we're going to draw 120 degrees. Let me label 0, 360. This is 90. This is 180. This is 270. Okay. So let's do what did I say? 120 degrees. We're going to go past 90, and then it's not quite halfway in between 90 and 180 because remember that's 45 degrees more. It's only, so to get from 90 to 120 is only 30 degrees more. So we're just going to do a little bit extra here. So let's say this is 120. Oops. All right, 120 degrees. Find the coterminal angle. Well, the coterminal angle is this yellow part. It's just what's left of here. And to find that, I'm basically going from, I'm going to start here, same initial side, and instead I'm going to go the negative way to here. And what's left of that is whatever's left of 360, which is going to be 240. And because we went negative, we're making that negative 240 degrees. All right. So these have to add to, if you just treat them like positive numbers, they have to add to 360. Okay. Cool. And it doesn't have to be 360. And what I mean by that is 360s also can be 720, right? So it's just multiples of 360. You do 720, you do 1080. For those that like watch snowboarding or like skateboarding, you know, when they do those tricks, they're just rotations, right? So like a 360 on a snowboard half pipe. If you watch like the Winter Olympics or anything, that just means they're, you know, that trick is you're fully rotating 360 degrees. 1080 means they fully rotate 3 times, which is crazy, right? Super hard. Anyway, so you can have multiples of that. So as long as you're adding to one of these, you're a coterminal angle. Okay. Anyway, all right. So cool. That's coterminal. And then reference angle is the last one. So let me erase this here. Oops. All right. So reference angle is, think of reference angle as, a reference angle is something that has to be less than 90. Okay, so reference angle, it's whatever angle you make, it's whatever angle you make that is the closest to one of these four sides here, right? So one of these 4 axes sides, okay? So that's why it always has to be less than 90, because if I draw, like, let's say this is 120 again, right? This is 120. the reference angle is the one that is the closest, is the one you're making with the x-axis. Let's just say it's with the x-axis, actually, not all four, but it's with just the x-axis here, okay? So, and it has to be less than 90. So that the reference angle is whatever this is, because this is 120, technically with the x-axis, but we want the reference angle is the angle you want that is smaller than that. That's still with the x-axis only. So what's left is basically what adds up to 180, because if this is 120, the rest adds up to 180. This has to be 60 degrees. Okay, so here I've got 180 total. So the reference angle is basically what's left of to get back to the x-axis. Okay, and in this case, it's whatever makes to 180. Now you know that can always change. So if you instead do if I do a reference angle that is let's say here, and then let's say I go to, let's say I go somewhere like right here, like 200. degrees, right? Well, the reference angle is, again, this small part. I need to look at this terminal side here and make this terminal side here to make an angle that's less than 90 that goes back to the x-axis. And the only way to do that is to go back to here to 180, right? So this is my reference angle, okay? This is my reference angle. And the measure of it is, well, the red was 200. Going back to the x-axis is 180. So it's going to be 200 minus 180. So it's going to be 20 degrees, right? It's whatever's left over. It's really just like intuitive, you know, like don't get caught up in the, like there's nothing to memorize here. It's just intuitively thinking, okay, what, like if I rotate a certain amount, what's left, right? So that's like the best advice I can give. Yeah. That's pretty much that. Let me know if you have any questions. We can kind of do another one real quick here. Like if I do another reference angle, let's say I do another reference angle that's, let's say down here, right? Like here's 270. So let's do initial side. Let's end my terminal side. Let's say this is like 280. So a little bit more than 270, right? Well, in this case, my reference angle would be the yellow to go back to here, right? So I start here, and now I'm measuring what's left of here. Well, in this case, now you're figuring out what's left of 360, because to get from 280 back to the x-axis is back to 360. So in this case, you're saying, okay, well, if I was at 280, how do I get back down, get back over here to this area, which is 0 and also 360. You just use that to help you. 360 minus 280 is going to be 80 degrees, right? So this yellow is 80 degrees, because that's how to get back to the x-axis. So it's just depending on where you are, you have to use different numbers to help you figure out what's left, okay? All right, let me know if that helps. This is the first part. There's one more thing I'll make a quick video on, but let me know if that part at least makes sense and if you need help. All right, thanks.